Okay, here's our video on linear functions. This is an assessment review, so we went over some of this stuff already. Just to go over functions. So a function is a relationship. It's a relationship between two items or two concepts. Let's say, for example, we had a toy, whatever the toy may be. Let me get a better marker. So let's say we had a toy in a toy store, whatever the case is, and it has a price. So it should have one price. Whatever the toy is should have one price. If you go into the store, let's say it's a toy truck, and it has two different prices, and it's the exact same thing, you would question that, right? So a function we'll call the toy X and the price Y, or the cost. So as you can see, this wouldn't be a function because the same item has two different prices, so it doesn't make sense. And that's how we'll deal with functions. So functions, we have an input. We have an input. We're going to input information into a box, in this case a linear equation, and we'll get an output. So that's a function. So the input is the domain, and the output is the range. With the toy was the input, and the output was the price. So we can look at linear functions, and we're talking about linear now, and remember linear, bring out the word linear here. Linear means straight, so we're looking at straight lines. Now functions don't have to be straight, but they have to pass a certain test, which I'll talk about in a minute. So let's look at one. Here we have a linear equation, and we can have a function. And just to review this, so the way we write this in slope-intercept form is y equals mx plus b. And we know that m is the slope. In this case, 3 is the m, so 3 is the slope. It's also called the rate of change. It's important to remember that the slope is the rate of change. The 9 is the intercept, the y-intercept. This is where, if we made a rough draft, that the line is crossing 1, 2, 3, 4, 5, 6, 7, 8. We'll just say that's 9. The line is crossing at the 9, positive. We know it's positive, so this line is going up. So that was just a rough draft on that. So here's something important that we need to go over when we do slope. Make sure we understand that. So again, we had a rough draft. Bring that down. And let's just say that was the number 3. So we know that the line is cutting through the 3. So if I made this line, we want to put arrows on our line. Make sure you put arrows. So we know that this is a positive line because from left to right it's going up. It's a positive line. The y-intercept is 3. We don't know what the slope is yet. So this is y equals mx plus 3 because we know it's going through 3 on the y-intercept, on the y-axis. Remember, this is the y line, that's the x line. Now, it's important to know about slope that the steeper the line, the higher the slope. So make sure you know this. The steeper the line, the higher the slope. So if we had a rough graph, so let's say we had a line going like this, and we had another line went like this. So we know this line will have a higher number slope than this line because it's steeper. Just think of a roller coaster. When you're going up the roller coaster, you're anticipating the dive, right? And then there's a dive. Of course, in a roller coaster, there's a curve, so it wouldn't be linear. But so in the roller coaster, you're going up, or if you're going up a hill, that's the slope, that's the gradient. So let's look at 3 lines on a graph. So this line has a slope of 2. This line has a slope of 1, and this line has a slope of 1/3. So you can see the one with the 2 has a steeper slope. Very important to remember that. So if you saw a line, you could determine if you saw two lines, that is, you can know for sure which one has the higher number slope. So if I put a line here, let's say I had a line going like this. So we know that this slope is 1, so this has to be lower than 1. Right? You have to use some common sense and logic. And we know this line, if I drew a line here, that slope should be what? That should be higher than 1 and lower than 2. So remember that, the steeper the line, the higher the slope. So let's look at this. So line A, line B, and line C. Which one is negative? Well, line C is negative because it's going down from left to right. Which one has the higher slope? B. B's steeper. It's going up. Line A is not as steep as line B, so line B has a greater slope. And line C is going down, so it has a negative slope. So we know that has a lower slope than line A. And as you can see, that all of these lines, though, are going through 0, so they're all proportional. They're all proportional lines, which we went over. Which one has the larger slope, the larger number slope? Which line? Remember, the line with the steeper slope has the larger slope, right? Obvious. Okay, so let's see if we can find the equation of this line. The middle line, what is the equation? So we have y equals mx plus b. And this again is in slope-intercept form. There's a standard form that we're going to go over soon. And we need some points here. We need some pairs on the grid. So here's one going, it's pretty good. It's 2, 2. So 2, 2 is 1. And here's 1, 1. And you probably can figure out what the slope is right away. But if you don't, remember it's the change of y over the change of x, which is rise over 1. So we have 2 minus 1 and 2 minus 1, which is 1 over 1, so we know the slope is 1. So it's going up 1 over 1. It's going up 1 over 1, up 1 over 1, up 1 over 1, forever. And it's going down 1 over 1 the other way, forever. And you see those steps it makes. So we know that the slope is 1. So if this slope is 1, this slope has to be less than 1, and this slope has to be greater than 1. So that's important to remember. So what is the rest of this line, by the way? What is the equation of that line? Well, so far we have y equals x plus b. It's 1x. Slope is 1, but you don't need to put the 1 because it's just x. Okay. By the way, if that's 2, that's 1, that's 0. You know it's going through the origin, so that means b is 0. So basically, y is just x. Y is just x. Remember, if it goes through the origin, it's a proportional relationship, and there is no b. B is 0. You don't have to put x plus 0. You don't have to write. So let's review again that when we're dealing with functions, we're dealing with the output, which we call f of x. You'll see that a lot in 9th grade. This says f of x. So it's basically saying we have an input x. Whatever we put in for x, we're going to get a function, we'll get a relationship, and we'll get whatever y is. So f of x equals 2x plus 1 is a function. It's a function of x. And all we have to do is just plug in an x. If I plug in 1 for x, I'll say f of 1. That just means that x is now 1. So 2 times 1 is 2, plus 1 is 3. So f of 1 will be 3. What do you think f of 0 would be? F of 0. Again, now we're saying that the x has to be 0. What's 2 times 0? 0. What's 0 plus 1? 1. So f of 0 is 1. What about, we'll do f of negative 3. See if you can do that one. Again, the input is negative 3. That's what it's telling us. So f of negative 3 is, we say 2 times negative 3, which is negative 6, and negative 6 plus 1 is negative 5. So that is a function. Functions don't have to be linear. I said that in the beginning. But they have to pass a test, and it's called a vertical line test. So if you can take your pen and you can create a line, right? And let's say you just draw vertical lines all through the graph. And if your line goes through whatever you drew, in this case the circle, once, then it passes the vertical line test. As you can see, when we drew this line, it went through the circle once, then twice. Do not include the axis. Don't include the y and the x and the y axis. So it went through the circle twice. So that's not a function. What about this parabola over here? So if we draw a straight line, it went through the function twice. Not a function. Okay, so what about this linear equation right here? You draw straight lines, it only goes through that line once. So it passes the vertical line. If you draw a line on this parabola, it only hits once. So it passes the vertical line test. So you draw a line and it goes through the line, whatever function you had. If it only goes through once, it is a function. Now straight lines, straight vertical lines are undefined. They're not a function. So if you had a line like this, we know that is not a function. Remember in the beginning of the video we said, a toy can't have, the same exact toy can't have two prices. It doesn't make sense. If I was selling this green marker for, let's say, $0.25, right, and I had two prices, one was $0.25, one was $1, and they're the same thing, you would question the clerk, right? You would say, well, why is this $1 and why is it 50 cents? It's not a function. It doesn't make sense. So it's very important. If you make a domain and range box, which is an input-output box, I have an x and a y here. You should have one x for one y. So if x is 1 and y is 2, then if x is 1, y can't be 3 because it doesn't make sense. That's not a function. 1x for 1y. So erase this. But you can have different x's for the same y. You can have this. This would be a horizontal line, by the way. Okay, we'll talk more about functions in part 2 of this video.